one is negative, one is positive. Yes? Therefore, bisection fail if you have a function like this. It won't work. There's no positive or negative. Yes? If you pick a point here, they're both positive, there's no roots. You can't choose them. So this technique will fail if bisection method used. Okay? But for secant method, if you have a root like this, if you have a function, let's just say you have a root like this, yes? And you pick 2 points, here's A, B. That means you narrow down with, here's A, here's B, here's your new C, yes? Right? Then if A, B is bad, choose this to be A, choose this to be B, so here's your 2 points again. If I cut this again, here's my new C. You see how this thing will narrow it down as you update A, B, get your C? Yes? So if this is, now this A, B give you the C. Now if A here is bad again, call this A, call this B. So here's your f of A, here's f of B, narrow it down again. You see how it narrows it down to the root itself? You draw a secant line, it's always narrow to that root. Right? So this is how secant method works. And that's also true when a function is just touching. If you have a function that just touch, it's okay too. You pick A, B here, here's A, here's B. Here you see, yes? And this is, here's A, here's B, here you see, yes? If you keep on update your A, B, and you still narrow it down. So you pick 2 point, narrow it down, update your 2 point, narrow it down, update the 2 point, narrow it down. Doesn't matter. It doesn't matter if you just touch or cross. Now for polynomial it's very nice, because something cross we call that root have multiplicity on. Multiplicity. Remember the multiplicity? No?
Vaguely.
You should.
It's a little bit.
They have multiplicity. If the function that type, you have even multiplicity, just like x minus 1 squared. This means when x equal to 1, make this 0, but this 1, at x equal to 1, it touch, not cross. If I have a cube, it has to cross at x equal to minus 1, x equal to 1. Right? Very important. Bisection only be able to search with something that cross, not touch. Secant method doesn't matter. But there is a downfall when you're choosing a secant method. Why? What if I choose? Remember, secant method doesn't matter A, B that you use. You can always find out where it is. But the only one problem that you do, if you choose an A, B, then the line look like this, it never narrows down. So you never choose A, B, you have the function value is the same. It will blow up. It will try to search for infinity where they say can't do it. The computer will just stop. Fair enough? Is that okay? So this is how secant method works. Are we clear on this? Do you understand this, how this works? I want to show you how is the Newton method work. Newton method is the result from secant method. Newton method works when, if you pick A, so all they do here is, here is a point A comma f of A, yes? Right? Newton method works, instead of using any 2 points, they're using 1 point by using the derivative. And the derivative represents what? A slope of tangent line. So if I draw a slope of a tangent line here. So according to using the equation of a tangent line, this is will project it to this guy. I'm going to call this B, yes? Right? Is this your root? It is not. If it's not your root, cancel B here, let's call it A again, yes? If it's this A again, this is my point, yes? Then if this is the point, I can project my tangent line one more time, yes? If I say tangent line again, this is my new B. Is it the right one? If it's not, cancel this, call it A. You see, if you're using the tangent line to project onto it, you will always find that point. Yes. So what this means here is, if I have a comma f of a, just like for your exam 1, and we have f prime of a, so you have slope, you have a point, the equation would be y minus y1, which is f of a, equal to slope x minus a, yes? Is that right? Y minus y1 equal to x minus x1. Now, you want to find b such that the y value is 0, isn't it? So what you want to find b. If I plug b's in here, the y value is 0. Because if b, what is the y value here? It's 0. Yes? B is the x-intercept. Therefore, the y has to be 0. What this allows you to say here, this is turned out to be minus f of a equal to f prime of a, b minus a. Yes? Can I divide both sides by f prime of a? Yes? So this just turned out to be b minus a. Yes? I don't want to find a, I want to find b. So how do I get rid of a?
Add both sides.
Add both sides by a. Yes? So therefore b must equal to a minus f of a divided by f prime of a. Yes? So if you notice here, that's where the a minus f of a divided by f prime of a is equal to b. Does that make sense?
Yes.
What is the problem here?
Same thing the second one.
Same thing when you cannot choose this to have the derivative. Because what is the derivative go to 0 look like? A line look like this, right? How could you project a line look like this? Okay? So there is some problem. But you will see the trade-off here is your computer code run much faster. If you look into computer project 1, if you find the code using bisection, maybe 20 to 30, 40 steps. Second line, 5, 6 steps, stop, right? 10 steps at most, right? This one very much the same. Very fast, extremely fast. Everybody that uses computer code is using this guy, Newton method. Very fast, very quick, efficient. However, there's a downfall to it. It's only work in a region. If you search for a root somewhere, right? If you have a root some places, and you guess over here, it might not go to that root. I give you an example why it's not going to that root. So be careful, try to choose a root. So if you have a function look like this, so you have root here, and root here, yes? Is that okay? No, I should do something like this. Yes? What they're saying here is, if I choose a root, a starting point over here, that means this point is what I'm looking for, that means the tangent line will go to that root. Yes? But if I choose some point over here instead for my starting point, so that means this is my point, so this is will project to this root. You see that? Even your starting point closer to one root, it might go to a different root. Does that make sense? So I don't want you to worry about it, I just want you to just randomly plug in some numbers in there, see how many roots can you come up. And then plot the graph to know how many roots in there. And now let's find all of them. How do I choose it? Okay? Before you do it, don't plot the graph. Randomly choose a number in there. It should work. It should give you something. If they give you a root outside of your interval, stop. I don't want it. Yes? Does that make sense? Now, what is quadratic inverse? Well, the word inverse is quadratic. Yes? The inverse quadratic. You know what quadratic equation look like? What does quadratic equation look like?
Ax squared plus
It's a parabola. Yes? Ax plus by and so on. So a parabola like this. Yes? The quadratic function is look like this. But the inverse, if it look like this, the inverse is this way. Yes? If this one, this way. what quadratic inverse is. Means that you inverted the x to y, y back to x. Okay? So how is this thing going to help you find roots? So this is the result from what we know as the Lagrange. What we call this is Lagrange interpolation. So what Lagrange did is this. If I have a root, if I have a function that have a root, so let's say here's my function, yeah? So I want to search for this root. The interpolator do this. What the interpolator, quadratic interpolator is, choose 3x value, so 1, 2, and 3, yes? So this is the 3x value. This is the 3 function value. If you have 3 different function value, can you come out with a parabola? If I give you 3 points, can you come out with a parabola to map those things? Yes? But this is not any parabola, it's the inverse parabola. So not looking to map something. Regular parabola would open down like this, yes? But I want to find an inverse parabola, so I'm looking like this, yes? So I can come up with a parabola that's mapping this. Would you agree that this might be the parabola that do that? But that will cross the x-axis over here. This is your new A, B, C, this is your new D. Yes? Now that's going to be wrong, yes? If it's wrong, therefore, don't call this A, B, C, D. Change this. Call this A, call this B, call this C, yes? Right? Remember, you have A, B, C, you get D. And if it's wrong, you change it A to here, B to here, C to here, yes? Now you have a new 3 function again. 1 here, A to this one, and B to this one, yes? Now draw a parabola one more time. Then go through those 3 points. That is your new D. Does that make sense? Now if your new D is not good enough for you, change this. Change this to A, change this to B, change this to C. Now you have this function here, and this function here. So if you cross another parabola that cross those 3 points, that sends her to whatever. So this is like the Newton method is project using a linear line. If it's not good, look again and aim again. Yes? Just project using a line. This, using a curve. Yes? Does that make sense? So this is the idea. The upside, this line, you might overshoot it. This going might be better. Yes? If you're using a tangent line, you overshoot it this way. Yes? Right? You start with a point, you overshoot it. But if you use quadratic, they curve towards. But the downside is you have to use more point, more evaluation, means that more point, more work. Less work, little bit of problem. More work, maybe go there too, but a lot more work. So sometimes we talk about like work and efficiency and so on.
What if the third value is on the other side?
It doesn't matter.
What would it look like?
If you have a function look like this, and you pick a point here, and a point here, yes? A parabola maybe is a starting parabola look like this. That means this is a point. Yes? Maybe if this is a point, so here's if this is your 3 point. So after you update it, I don't want this point. I want this one, and this one. Yeah? That means your next parabola might be this way. That means you still narrow it down. Yes? The parabola either be this way or this way.
That was good to know.
That's what inverse parabolic is. Okay, we still narrow it down. So if you have this point now, that means if I want to narrow, now I stop this point, yes? 1, 2, 3 point here. Very quickly. Just to draw, you almost get there, right? Does that make sense? So this is very powerful. Let's talk about how to code this. I will post this image on the sample code online. So if you want to just follow along as we do this. So you can open this code one more time. Let me just define you if I said A equal to something, B equal to something, my C must equal to B minus f of A, f of B, times B minus A, divided by f of B, minus f of A. This is sequence method, yes? Then you update A and B, and so on. Step 1, write out the techniques here first. Let A equal to something. Let's just randomly let A equal to 1 just for writing purposes. Let B equal to 2. Make sure you choose A and B at different points. Otherwise, how could you have a secant line at the same point? Yes? That means your C must equal to, first thing I always like to write just the way I have there. Yeah? So C must equal to B minus f of B times B minus A divide by, so when I divide, I always put a parenthesis, then I fill in the blank. F of B minus f of, and make it look nice. Is that okay? Now, this is the concept. If it's wrong, you do it again, right? While it's wrong, so this is you using the same technique, while the absolute value of B minus C, or C minus B, doesn't matter, B minus C, still big than 10 to the minus 5, right? If B and C is not close, still big, you need to update A and B, yes? What is A equal to then?
B.
A equal to B and C. B equal to?
C.
C. After I update this, I need to find my new C again, yes? And my solution, my final solution should equal to what?
C.
C, whatever C, the last C that I have, right? So that's my last step. Does that make sense?
Mm-hmm.
So this is the flow chart that we begin with. And now let's define what f is, yes? How do you define a function? So this is, let's work on a function that we know the answer of. What function do we know the answer of?
X squared.
X squared, right. F of x equal to x squared. And what is the solution? Let's just do x squared minus 1. Let's say x squared minus 2. So we know that the root is square root of 2, yes? So how do I define this into FreeMat? So this is how you do this. F is equal to at parenthesis x, close parenthesis. This tells you that f is a function of x. And how do you define x squared minus 2? If you put into another parenthesis x squared minus 2, this would automatically show that anywhere else you have f of b or f of a, they automatically pick it for you. You don't have to go there and type in the function in the place. This is called a function call in computers in MATLAB or FreeMat. Yes, function call. So I know the root here is square root of 2. Let's run this. Yes. What's the answer for square root of 2? What's square root of 2?
1.414.
Okay, let's save this. Let's call this here is sec 1. It's secant method, so secant method, let's call this M. I'm going to save this on the desktop. Oh, wait a minute, put it back. Undo. Yes. Put it in the desktop, save this. Let's run this guy. Now look at what the answer is. Better yet, let's do format long. To make sure you display more decimal places. Let me show you what square root of 2 equal to exactly. So if I just want to say what is square root of 2, okay? Here is the exact answer for square root of 2, and using secant method of finding this root, it gives you up to here correctly, yes? Correct? My secant method just expected to stop at 5 decimal places correctly, however, compared to actual result, they actually give you 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places correctly. Comparatively, yes? Right? So how many times I actually do this?
To do the count.
How do we do a count?
Count equals
Before I do anything, what is my count?
0.
0. Oh, wait a minute. Let's make life simple. At this step, I did 1 time secant, yes? At this point here, I found my secant step 1 time already, so my count here should be 1. Every time I do this, I just wrote my count equal to count. Yes, I add 1 to my old count. So let's just semicolon all this. I don't need to see all this thing. I don't need to see all the update. All I want to see is the solution and my count equal to count, yes? Is that okay?
Mm.
So if I save this, run it again, so how many times? With this A, with this B, how many times did I actually do this, guys? 5 times. I do secant method 5 times, give me the same root. Now, what if I don't know where the root is and randomly choose? I'm going to choose 100 and 200. Will they still give you the same some roots, yes? So save. 15 times. It still gives you the same root, isn't it? And probably about the same order of magnitude, yes? The same error, right? But you do more because your root is at 1, you guess at 100. Does that make sense? What if I said I want to change my functions to some other function? If you have more functions, you can define more. Let's say I'm going to define this function sine of f. Yes? Yes, sir.
Wouldn't you need to change f, so it'd be like f2 or something?
You don't need to.
No.
You want this to still call f. Don't want to change f1, f2, f3.
But how to know which one to call?
The computer always read from top to bottom. The last one to see what f is, that's what they remember. Just like when you were born, I said, hey Tom, beautiful Tom, right? But when you turn like 1, I said, Smith. You might not remember what Tom is anymore, you just know Smith. Right? And I change the name again when you turn 3, call you Ed. What's the last thing you remember what your name was? Ed. But I don't want you to do that. Here is the proper way to do this. You can put a % sign in front of this and it turns red. What the red line is computer never read it. It's common. You comment out the function that you don't want to run. If you don't put % sign, it's the function that you want to run. Now let me ask you this, sine of what is 0? Sine of 0, right?
Mm-hmm.
What else? Pi also is 0. So pi is 3.14, yes? I'm going to get something around pi and I hope that the secant method will give me pi. Yes? If A is 3 and B is 4, let's see if it will give me pi. Yes? If I save this, now I'm solving a different function now. Yes? Is that pi? 3.14, is that pi? 3.14159.
Yeah.
Yes? It is pi. Close enough. 3.14 is all I care, right?
You care at 5 decimal places.
No, I care with 5 decimal places, not to the exact solution. I don't care about the exact solution.
Huh?
I need you to approach this problem knowing nothing about the solution. Hypothetically, do you know the solution to this guy? Okay, when you don't, then start by not knowing. If I ask you, is there a solution between 0 and pi, just randomly choose a equal to maybe 1, b equal to 2. What I want is I want you to play around with that a and b in there. Randomly choose weird thing in between 0 and pi. Yes? Pick anything between 0 and pi. We will give you some roots. Yes?
Why not choose 0 and 5?
You could. Can you use 0 and pi over 2? Can you use pi over 4 and pi over 3 or something? Choose randomly. Yeah? Please do that. It will give you some different root. So your root has to be between 0 and pi. If your answer turns out to be anything negative or bigger than 3.14, I don't want it because it's not inside this interval, and why do I care? Right? I only want you to find your root within that interval. Are we clear? Good? Now, let me show you quickly and how would you define, how would you do a Newton method. So I'm going to copy this and go to a new one and paste it back. Now, I want you to remind you what Newton method is. This is Newton method, yes? So you need two things. You need a function and the derivative of a function. But you don't need 2 points. You need only 1 point. So I don't need a. So I'm going to get rid of b here and get rid of my function here and get rid of b here. Get rid of this guy. Get rid of this guy. And now I only have a and b, so this would be a difference between a minus b, yes? Does that make sense? Right? So the first thing is you said a equal to something, and what is your b? B equal to what?
4.
What?
4. 5.
No. Newton method is this guy, yes? Right?
Mm-hmm.
Newton method B said a minus f of a divided by f prime of a, the derivative of a. So how would you like me to call the derivative of a? F primes? F1? Let's not do F1, let's call it F primes. Is that okay? Right? Yes?
At the bottom, when you say solution equals C.
Wait a minute, we're not going there, we modify this as we go, right? You see how I modified the previous ones? I just copy and paste the same thing. I have A, now I find B, I count this is 1, and if the absolute value of A and B is still big, I make B is my new A, and what do? I need to find my new B, yes? And if I find my new B, I count again. Does that make sense?
Mm-hmm.
Are we good? And your solution should equal to what?
B.
B. But notice here, you have F, right? If I want to find F here, I know what F is. But you need to also define. So how do I define F prime? If F is this, F primes equal to at. Somebody tell me what the derivative of sine of x is. Is that okay? So I define it just like I define a function of f. So if I save this, let's call this is a Newton method. Please do not call it Newton. Because the FreeMat have a function called Newton. But they do more complex than what we're doing here. Okay? Call type Newton method or something, okay? Don't call it Newton. Newton is like keyword in there. Save this. Now I should be able to run this guy. Let me just open this side by side. I'm going to run Newton. Now look at that.
Man, 3.
How many steps did I run Newton to get 3 points? Last time secant method to do what? 5. Let me show you another thing to think about here. If I want more decimal places, let's say I want 10 decimal places. If I want 10 decimal places for secant, okay? I want to show you how many steps that secant take. Same step, yes? But this one, it starts to repeat itself very quickly, yes? And how about Newton here if I want 10 decimal places? 4, still less. Yes? Let me show you the x squared instead. Just do percent here. Remember I did 100 and 200? Right? How many steps I get to this? For 10 decimal places, I do 16 operation count, yes? Now, for Newton method, now for each one of this, for Newton method, that means you also have a prime for each function that you do, yes? So if this is my f, what is my f prime here?
2.
Make sure you're using proper parentheses here. Time 2 times x, yes? And if I choose this to be 200, let's just say I start at 200, yes? 10 to the minus 10. 12 steps. I get 10 decimal places from this guy. Yeah, Newton method is ideally less. And notice that every time I have Newton method, I always have to define 2 things at all times, f and f primes. So what I want you to do is pairwise your f and f primes, so you know that if I comment this guy, I go to the next one, I know exactly what it is, yes? Now the reason I gave you that long, crazy function, I want you to make sure that you learn how to punching things correctly. So what I want you to do is write it by hand. How would you write by hand on papers? And all you do is start to punching as you go. Parenthesis, x, close sign, parenthesis, x, close parenthesis, and so on. Yes? So write it by hand first before you dump it into the computer. Does that make sense? Now, I want you to really play around with this guy here. Now you have A, B, C, D. All you need to do is f of A times f of B times C divide by parentheses. Make sure you do proper parentheses, by the way, because this is divided by this 2 combined. This different, this different. You have parentheses issue, do you? Not parental issue, just parentheses issue.
You gotta put me on blast.
I had lived with my parents more than half my life, so I have parental issues. They can't say anything to me most times, but I still listen. Okay, we're just dealing with parentheses issue. Okay, are we all right with this? Does that make sense? So make sure you. The same thing here. You have A, B, C, D. You find D. That D is that long function. So I suggest you do this. Here's what you should do. You have A, B, C, right? Before you find D, I'd like you to split this into 3 pieces. Part 1, part 2, and part 3, yes? Is that okay? Because everyone's in here is just involved with A, B, C. That's right, yes? And f of A, f of B, and f of C, yes? So pick this. Call it P1 is equal to the first piece, P2 equal to the second piece, P3 equal to the third piece, yes? Make sure you just call this P1, P2, and P3, yes? And what is your D equal to? Copy and paste this again, put inside your while loop. and update them. All right? You finish the project, you should really finish very quickly. Yeah? My timeline for finish your project here, at least